Hi everyone. Today's supplement to the lecture is to lecture 6 on loops. And I'm going to start off, I'm going to combine both Excel and Python to show some details about what a loop is and how loops are thought of. We don't formally actually have loops in Excel, but we're going to start here because the copy and paste and sort of drag function of Excel is very similar in many ways to using a loop, and I think it'll help us understand loops better in Python. So that's where I'm going to start first here is in Python. So in this example, first here in Excel, and in this example, we want to determine if a number between 0 and 20 is a factor of 3. And we're going to use a new function maybe you haven't used before, but that's really quite useful with loops, which is the mod function. And the mod function gives a remainder after division. So if I say have 2 divided by 3, that gives me a remainder of 2, and so the mod function would just return a 2. Whereas if I have 3 and I want to divide by 3, then the mod function is going to return a 0 in that case because there's a 0 remainder. And so that'll help us understand if something's a factor. And so what I'm going to show here is just a simple copy and paste kind of thing that you do all the time in Excel. So I'm going to put the different parts of the loop. Remember that a loop has a condition, and often that condition is driven by a counter. So I'm going to have a counter where I'm going to start counting with 0. And in programming and Python, in Python specifically and programming in general, we often start counting with 0, which is a little bit of different and takes a little bit of getting used to. But in this case, so we start out counting at 0. And I'm going to want to go all the way up until I get to 20. And so in Excel, remember, you can do this pretty easily by just doing 0, 1, 2, 3, and then dragging down. Another way to do that is to make a variable that equals the cell above it. So I say I'm going to equal that cell above it plus 1, all right? And then I go to the next one below it, and I say I'm going to equal that cell plus 1, and so on and so forth, all right? And I go from 0 all the way up to 20. And then what I want to do is evaluate the modulus, or use the mod function, of what my count is, and I want to have the divisor be 3. So you can see here I have equals mod B17, which is the guy right next to it, the count, and then I'm dividing by 3, okay? And that tells me, 0 doesn't have any remainder, but then I have 1, it has a remainder of 1, 2 has a remainder of 2, 3 doesn't have any remainder. And you see that this mod function just goes 0, 1, 2, 0, 1, 2, and it repeats all the way down, okay? And then the last thing I do is I want to print whether or not 3 is a factor to that number in the count. And so I have an if statement here, which maybe practices a little bit of our if statements we used last time. Say if mod count 3 is 0, so if you say if this number right next to me is 0, then write into that cell 3 is a factor, and if not, just leave it blank, okay? And I can copy and paste that all the way down, just like I can copy and paste this all the way down, just like I can copy and paste this all the way down. And so each of those things, if I just copy, paste, 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 paste all the way down, and so you can see that I can take a row like this row, and I can just drag all the way down, right? And it gives me out what are the factors of 3. So what are the factors of 3? Of course, 0, 3, 6, 9, 12, 15, and 18 are all factors of 3. All right? And so this is very much like a loop. It's not a loop in Excel. I've just defined something, but then I've made each row below it something that is exactly the same formula applied to the row above it. And all I have to do is drag down. And hopefully this seems familiar to you, but is also a little bit structured in the sense that I have this count, and I have something that's operating on the count, or something that's operating at that given count, or multiple things that I need to store. And then just dragging down to repeat that sort of copy and paste operation is similar to what we're going to see in loops. Okay, so let's practice this in a case where I don't have the example written out. So what this says is use an if function to determine which years are leap years between 1990 and 2020. Print leap year for years that are. Okay, so what I'm going to do is I'm going to start, I want to start at 1990, okay, and I want the condition, so if I come back here and look, what do I mean by condition? I meant that's the thing that's going to end my loop. So I want, maybe I'm going to say year is equal to 1990, and I want year to be less than or equal to 2020. So that's the condition on which I keep going through the calculation. Okay, so what is the statement? The statement that my loop will execute? Well, it's very similar to this one. I want if the modulus of the year is divided by 4, right? If that equals 0, then I'm going to want to print out leap year. And if not, I'm going to not print that. Okay? Here we go. And then I'm going to stop when count reaches 20. So in this case, I want to stop when the year equals 20. Okay? I'm going to just check real quick and make sure that I didn't mess up the syntax on that one. But I think that's what I want. Yep, if mod count 3 equals 0, booyah. Okay, so this I'm going to put in the year here then. So the year is the thing I need to worry about in my loop. So I have the start, the condition, and the stop. That's all based on the year. Well, the year is 2020. This guy I'm going to have be the modulus. Mod of year 4. Okay, so here I'm going to start year 1990. And let me play the same trick I did before. I'll do this. So to get the modulus of this, I do equals mod. I want to go to the left there, look at that 1990, and 4. Okay, and so 1990 has a factor of 2. So in the leap year, I'll say if that guy next to me equals 0, then I print leap year. And if not, the value of false is just a blank cell. Okay? So that's the first time. So now how do I do it a second time? Well, I want to increment that by 1. And I just want this same mod function applied to the one right next to it. And this same if function applied right there. And again, that works. Now all I have to do is copy, paste, 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 right? As I paste down, I'm just repeating exactly what I did that second time in the third row, the fourth row, the fifth row. So as a matter of fact, I can just highlight these rows and drag down until I get to the year 2020. So let's see how far that goes. 2010, 2019, 2020. Okay? And so 92, 96, 2000, 408, 2012, 2016, and then this year, 2020, is a leap year. Okay? So that's an example of loop-like copying and pasting in Excel. So having done that, let's switch over now to Python and explore a little bit more loops in Python. All right, actual loops. And loops are one of the more powerful things that you can do in programming, because it allows you to do this, but all in one line instead of having to copy and paste like Excel. And so this is a super useful thing that you can do. So the first thing I'm going to highlight for you is to show you the syntax of while loops. So the basic idea in a while loop is you have while, and then you have some condition, okay, that we talked about before, and then you execute the statement. And when the condition evaluates to true, the while loop runs, but when the condition evaluates to false, the while loop won't run. So here's an example of a while loop. Let me put this here so we can run it. Okay, what this says is I start out with some variable I call I set it equal to 0, and I say while I is less than 20, continue to go through my loop, or we would say iterate through my loop. All right, and inside the statement that I run each time is I increment I by 1. Perhaps this is the first time you're seeing this type of expression. This plus equals sign is just like in Excel where I say look at the one above me and add 1 to it, except I'm doing it to the same variable. So I say take I, add 1 to it, and put it back in I. So it's an in-place addition by 1, or an increment of 1. All right. I can make it increment by other numbers by putting a 2 or a 5, or I can even make it decrement or go down if I make that negative. Right? And then I print I. So what happened when I ran that? So what happened is the very first time I had a 0 was less than 20, so that I evaluated to a true. So then 0 plus I had I, which had a 0 in it, plus equals 1 goes to 1. So now I becomes a 1, and I print I, and I get a 1. Then I do it again. Okay, I go back to the top here. That's the loop part of the loop. And I say now I is 1. Is 1 less than 20? Yes, it is. 1, add 1 to that guy. That gives me 2. And I print a 2. 2. Okay? And then I said now 2 goes back. Is 2 less than 20? Yes. And it repeats again and again and again until I finally get to 19. So now I have I is 19. 19 is less than 20. So I do 19 plus equals 1. That gives me 20, and I print 20. Now when I have I is 20, I try and come up to here, and is 20 less than 20? No, it is not. So it doesn't do that, and it moves on. All right, so that's a basic example of a while loop. So notice that if I'm not careful, I can actually make what's called an infinite loop. Okay? So an infinite loop is something where in the while loop, this always evaluates to true, and so it never ends. And it just keeps running and running and running. So here I'm going to start out and make I 0 again. And then I say while true. Now you don't want to do this normally, and normally you wouldn't write while true, but maybe you would do something silly like I greater than or negative 5, and you're always adding, and so it never ends. Okay? So let me run this and show you what happens. So when I do this, look, it just keeps going and going, all right? And it'll just keep running forever. So it made it all the way up to 18,204 before I stopped it. Now how do I stop it? So I'm going to show you that again. So I'm running this, I hit Control Enter, and this is just running like crazy. I had to click over onto this console, and I hit Control C, all right? And Control C is what stops it, and that's called an interrupt signal. And it sent the interrupt signal, and that'll do that. So if you ever get an infinite loop, if your thing just seems to hang, try clicking on the console and clicking and typing Control C to interrupt the execution. Okay. So why don't you look here? Take a look at this code right here, and pause the video for a second and see if you can predict what is going to print. What will be the result of this code? Okay, so hopefully you did that, paused it. What did you predict that it was going to be? Well, it just prints I equals 5. Why does it do that? Well, it's because it starts out as 5, and then it says while I is less than 5, that evaluates as false, so it skips the whole loop, and it just prints this one at the end. What happens if this had been 0 instead? Well, what happens there is I run through this whole thing, and I do very similar to this loop up here, and I print 1, 2, 3, 4, 5, and then I print 5 again, because as soon as I print that one on 5, this as soon as I run I equals 5, now this comes back up here, this won't print, and it'll print an I equals 5 again. Okay? Okay, so now let's do an example that's similar to our Python example, and let's determine which numbers from 0 to 20 are a factor of 3. So we're going to start out and have count equals 0. Remember, we did this with Excel. Let me pull that up and show us, remind us of that. So I have the count here going from 0 to 20, and I need a modulus to determine that. So if I come back to Spyder here, how do I calculate a modulus in Python? It turns out I use the percent sign. So the modulus operator is so useful in loops that it doesn't even have a function. It actually has just a symbol that we use to get that. So I define this variable I call TMP, or as temporary variable, as the modulus of count divided by 3, okay, the remainder from the division. And then I have an if statement. If that equals 0, print 3 is a factor, and then I increment count, right? So let's run that. What happens? it just printed 3 is a factor, 3 is a factor a bunch of times. Maybe that wasn't super useful, but let me put count in there. And we can see what it does. Let me run that again. Oops, this says I have an invalid syntax. Oh, I wanted to put count, colon, 3 is a factor. Let me run that. Okay, so 0, 3, 6, 9, 12, 15, 18 all have 3 as a factor. Okay, so what happens if I forget to put the count plus equals 1 down here? What happens? Let me save that and run it. Oh no. Look, it goes in an infinite loop, but it's never making count go up, so it's just an infinite loop forever, printing 0, 3 as a factor, as long as I let the code run. All right. So I need to don't forget to add a counter when you're doing while loops. Okay. We could make it print very similar to what we had before. I can come down here and do print count, and if I put end equals empty character, it won't make a new line, and then I can get rid of this. All right, and now I run that. I print. Let's see. Oh, it's this one I want to make that has no line. Sorry, that confused me. I want to print count. Here, maybe that'll work better. It's still ugly. We'll just leave. We'll get rid of that. But if you look over here, this says 0. Maybe I'll do this, an arrow like this to tell us 3 is a factor. 0, 3 is a factor. 1, 2, 3, 3 is a factor. 4, 5, 6 has a factor of 3. 7, 8, 9, 9 has 3. Okay, so you can see that I'm looping through and doing 0. And this should give me the same answer as I had in Excel, okay? 0, 3, 6, 9, 12, 15, 18. All have 3 as a factor. Okay? So why don't, I'm going to let you do on your own, use the while loop and an if statement to determine the leap years between 1990 and 2020. You're going to want to do something very similar to this, okay? And do something similar to what we had in our Excel sheet to get the same answers based on leap years. And again, you're going to need to use the modulus, and hopefully that'll be some useful practice for you. Okay. So now I'm going to move on after we've done that practice, and I'm going to go ahead and do some for loops. Okay. So a for loop is similar to a while loop, except you have to have a counter, right? So in a while loop, you don't have to have a counter. You often want one, but in a for loop, you don't have to have one. So the basic syntax is right here. So I'll go ahead and wall this guy off. Oops, did it backwards. And we'll run this for loop. And if you look here, my for loop, I start out with some variable I. I don't even have to declare the variable before and I give it this range function. And range produces a list of things from 0 to just before this guy. So it goes 0, 1, 2, 3, 4. It doesn't include 5, but it has 5 numbers because 0, 1, 2, 3, 4 has 5 numbers in it, right? And so that allows me to make a range of these without having to put in, a conditional statement here. Okay, so that range allows me to do that, and then what I'm doing here is just simply printing what's in that. Okay, so let's look at. There's some different variations of things we can do in a range. All right, so if you just put it like this, that means you'll go from 0 through 4. But if you want to start at a different number, you can put in 2 numbers, and the first number will be the start, and the last number will be the end. So if I want to do from 1 to 5 instead of from 0 to 4, I can just put in 1, 5. And if I run that guy, oh, excuse me, I'm screwing up saying that. You have to be careful. This will start it at 1, but this end will still be like this end up here, and that it will end before it. So this one will actually only do 1, 2, 3, 4. So look at that right there. 1, 2, 3, 4. It doesn't include that last value. Okay? If I want to make it a little more complicated, I can also increment by more than just 1. So I can do counting by 2's if I give it a third number. And so that's what I have documented up here. I have the range, which has the stop, okay? I have a start and a stop, and a start, a stop, and an increment. So here I'm incrementing by 2. So now I'm going to do 0, 2, 4. But I don't go up to 6 because I end before that number. So if I run that one, you see 0, 2, 4. Okay? If I put a 5 in there, I'm still going to get the same thing because a 4 ends before that, counting by 2's. If I put a 4 in there, I get 0, 2. If I put a 7 in there, I get 0, 2, 4, 6. Okay? So I end, it's like a less than sign. You know, if you think about the while loop where I had I less than 20, I never reached 20. That's the same thing here. There's like a less than going on. Okay, the last thing to put is if I have a counter that's negative, it will count down for me. So if I run this piece here, oops, I forgot about my while loop above. If I run this piece here, I have 0, minus 1, minus 2, minus 3. Okay, and again, it doesn't include the minus 4. So I need to make sure I update that there. All right, but it doesn't include the minus 4. It doesn't quite get there. All right, it's like the less than sign. In this case, it's a greater than sign. So if I put a minus 5 in, it'll count all the way to the 4. All right, so why don't you sit down and pause the video rather, and look at these and try and predict the output of these loops without running the code first. Okay, so try and guess. I'm going to have this range here and this range here. What is this going to print? Do that before running it. Okay, so now let's run these and let's see what happened. Okay, the first one, let me comment this guy out and we'll run the first one again. Okay, the first one starts at 3 and it counts up by 1, 3, 4, 5, 6, 7, but it doesn't have 8. Okay, hopefully you got that one. Let's look at this one. This one is going to count by 2, all right, and it's going to start at 1, so it's going to go 1, 3, 5, and it's going to stop before I get to 6. And indeed, that's what we see. 1, 3, 5 stops before I get to 6. Okay? All right. So the last thing I want to show you about loops is that sometimes you want to do some things in loops, like you want to just stop. No matter where you are, you want to quit the loop. And other times when you're doing a loop, you get to some point and you want to skip the rest of the piece underneath the execution of the loop and go ahead to the next spot. So I'm going to show you what those are with break and continue keywords. Okay, so let's look at this example first. Okay, so I'm just printing an extra line here. Suppose I make a number 6, and I say for I in range 6. So that should count 0, 1, 2, 3, 4, 5. Okay, and I say if I is 3, print I equals 3, and then quit the loop. Okay, and I quit the loop by giving a break statement. However, if I isn't 3, all the other times it's going to print I equals I of n minus 1. Okay, so let me run that. Okay, and this goes I is 0 out of 5. So the first time I is in 3, doesn't do that. Second time, it doesn't do that. The third time it says I is 2 of 5. And the fourth time it says, oh, it gives me an indentation. It says I equals 3, quit the loop. Okay, so break allows it to run, and then once it reaches the break, it quits the loop at that point. Okay, I'm going to put this up here just to give me a little space. Okay, a continue skips everything in the loop below the continue statement, and then goes back to the top of the loop and keeps going. So continue just quits the rest of that part of the loop and then keeps going. So maybe the easiest thing to do is to run it to show you. Okay, so suppose I don't have this in here. We know what this should do. This should just print 0, 1, 2, 3, 4, 5. Okay, now if I put in an if statement and a print I equals 3 and run that, now it will print an extra I equals 3 right there. So I'll do 0, 1, 2, 3, 4, 5, but it also prints that extra I is 3, go to the next iteration. If I put a continue right there, what happens is it skips doing that line 145. Notice here I had an I equals 3 of 5. Down here I don't. Okay, it skipped that one, but it stayed in the loop. Okay, contrast that with the case that I had up here when I quit the loop with the break statement. There it printed I equals 3, quit the loop, and then nothing happened after. So this allows me to be able to do something like run something else in here but skip other pieces. Okay. All right. So that's break and continue. Finally, the last thing is that we can nest loops. Just like we can nest if statements, we can nest loops. So to nest a loop, you just put a loop inside another loop. So here I'm starting I outer, which is the outer loop is the one we call the one that's at the biggest scale, okay, the one that's furthest to the left, in range, and I'm going to go range to n outer, which is 2. So I'm going to do 2 iterations of that one, so 0 and 1. And then I have an inner loop that I'm starting right here that I'm going to do 4 times. So I'm going to go 0, 1, 2, 3. It looks like there's a typo there that I need to fix. Okay, and so what I'm going to do is run this and show you what happens. And then we're going to talk through what happens there. Let's see, I have I inner is not defined. Oh, I inner, I see. Messed that definition. Okay, so what happens here? So the first thing that happens is I come in and I outer is 0, so I print I outer 0. And then I go to this loop and I say for I inner in range up to 0, 1, 2, 3, it says I inner is 0, so it prints I inner is 0. And then it goes back, and where does it go back to? It goes back to this loop right here. So I keep going in this loop before I go to the back to the outside one. So I do this one, I do 0, 1, 2, 3, and then I go back to the top here, because I finished that piece. And now I do the outer is equal to 1, because I go from 0 to 1 for the outer, and then I come back here, and now I start over on the inner. So now my inner goes to 0, and I do 0, 1, 2, 3. Okay? So this allows me to do 0, and then 0, 1, 2, 3, and then 1, 0, 1, 2, 3. Notice this is kind of like a two-dimensional thing. It's sort of like I had 2 rows and 4 columns of some matrix. So nested loops are really useful for either assigning or accessing elements in a matrix. Okay? All right, so here's some practice to do. Let's do this one together. It says write a loop that prints all of the even numbers between 10 and 39, but skips 16 and 32. Okay, so we're going to do let's do count in range. Let's do, we want to go from 0, we want to go from 10 to 40, right? Because that'll count us between 10 and 39. Okay, and we want to print count. Okay, so let's just see that one real quick. There you go, 10 to 39. We want to do the even numbers though, so let's count only by 2. Now I do even numbers, 10, 12, 14. Okay, great. But now I want to skip 16 and 32. So let me do the following. If count equals 16, then I don't want to print that one, so I'm going to make that continue. Okay, let me run that one. So now I did. I do 10, 12, 14. I skip 16, go straight to 18, etc. So I can do that. And I say, okay, if count equals 16 or if count equals 32, now that should print that. And there I go. I print from all the even numbers between 10 and 39, but I skip 16 and 32. Okay, this isn't the only way I could do this. I could do this other ways. Okay, I could do for count in range 10 to 40. All right, and I could have if count mod 2 equals 0, that will, then I could print count. I could say if it's the modulus is equal to 0, that finds all even numbers. I could say and count equals 16 or count equals 32, and do that one. Okay, and let me comment this out so we can show that it gives the same thing. Oh wait, that does backwards. I want it, that only prints 16 and 32. I want it to be not equal 16 and not equal 32. Right there. Now I have 10, 12, 14. I want it, if count equals 2, let's see. I've messed up my logic here. Let's step back and think about this. I was going too fast. If count equals 2, then I want to print it. So I want it to not equal 0. Well, I want it to equal, if it equals 0 and count doesn't equal 16 and count doesn't equal 32. You got to flip your ands and your ors around when you have not equals. Now let me try that one. Booyah. Okay, there we go. If count doesn't equal to, or if count equals, or the modulus is 2, is 0. So if I have a remainder, no remainder when I'm dividing by 2, and I'm not 16, and I'm not 32, then I print that out. Okay? So that way also works. So, like in many things in programming, there's multiple ways to do it. One's using the range variable, and others using if statements. Okay, this one with the range and the continue is some good practice for that. This one down here is some good practice with some if statements and some more complicated logic. All right, so I think that's all I have for you. Let me just scroll down and double check. Yep, that's all I have for you. So, hope this video was useful, and we'll talk to you next time.